Hello everyone. Now we are going to start structure in C programming with different examples. Means what is structure, how we will define a structure, how we can declare a structure variable, how we will initialize the member of the structures and how we can access the member functions. In this lecture we are going to discuss all these points. So what is structure? Means structure is a group of variables of different data types presented by a single name. I am repeating, structure is a group of variables of different types represented by a single name. Let's take an example to understand the need of structure in C programming. Yeah, we need to store the data of students like student name, age, address, and its USN number or ID, etc. One way of doing this would be creating a different variables for each attribute. However, when you need to store the data of multiple students, then in that case you would need to create these several variables again for each student. This is such a big headache to store data in this way. We can solve this problem easily by using a structure. We can create a structure that have a member for name, ID, address, and age, and then we can create the variable of this structure for each student. This may sound confusing. Yeah, don't worry, we will understand this with the help of one example. So, how to create a structure in C programming. Here, I'm saying structure is a collection of elements with different data types. Okay. Next point is structure is user defined data type. Correct. Using structure, we can define a data type which holds more than one element of different types. Means like this is a syntax for structure. Yeah. Struct keyword is used to create a structure in C. This is the struct keyword we are using to this structure keyword we are using to create structure in C. This is a data type, structured data type. Struct keyword we are using, it is struct keyword is a short form of structured data type. And what type of data type is? It is user defined data type. This structured tag is the identity name, any name you can give, struct student, struct employee, struct school, whatever. If you want to collect the data and access the data or retrieve some information, so you can give any name to this structure. Okay, next, this is the example of a structure. We are creating a struct employee. Employee is the name I can identify by this employee name structure. Okay, this is the identity or tag name you can use, or name of the structure we can say. Okay, now open braces. These are the some member of structures: int, employee number, e number, character e name. E name means character e name is a character array, means this is a string, and size, what is how many number of characters you can enter? 20. This is the character array string. Float e salary, employer salary. Float salary means it is in float data, float, and e salary. So now the question is, why they introduce the concept of structure? Why they introduce the concept of structure? Means what is the difference between, we are using array also, and what is the difference between array and structure? So the basic thing is, using array we can store n number of elements, right? By using arrays we can store n number of elements. How many number? No matters, but they should be homogeneous elements, because array can only store homogeneous elements. So if I'm declaring int array 5, means how many number of elements it can store? Only 5 elements it can store, but it should be, if I am saying int array 5, means how many numbers? 5. 5 numbers it can hold, but they should be of same type. They should be of all integer type values. Okay. So in array, we can only store homogeneous data, but in character, in structure, what we can do, we can store different data types. We can store different type of data. Okay, using array, we cannot process information like employee data or student data or some other data. Single linked list, double linked list, tree, nodes, graphs, such type of information you can't store, because different type of information we need to store in this all cases. But like employee is like employee number. It is a integer value. Name is a character array, and employee salary is a double or float type. So in that situation, you must go for the structure only. We can't use arrays. One more important thing, suppose I'm defining a structure, struct employee, int e number, character e name, and float e salary. So data type is ready, structure is ready. So our one question is why they introduce the concept of array. It is clear because there is a more drawback with the array. We can only process our information with the same type, but in structure we can store different data types. Okay, but by just defining the structure, it will get memory? No, it will not, because here structure is ready. Means we have already defined the structure, employee and name. These are the member variables, member of structures we have already defined. So data type is ready, structure is ready. By just defining the structure, it will get memory allocation. We are just defining. This is the definition part. We have already defined, but how? By just defining the structure, it will get memory allocation? No, it will definitely not. This is just data type. How we have primitive data type? This is a data type only. Like user defined data type can be of two words, or collection of words. Here I am just using one word. It can be of two words or collection of words. Now the question is, when it will get memory allocation? We have just defined, I am writing struct employee, int name, character e name, float e salary. So by just defining the structure, it will get memory allocation? Definitely not. When it will get memory allocation? Now the question is, when it will get memory allocation, how we need to allocate the memory? So for this, we need to create the variable, structure variable. We need to create a structure variable like this. I'm writing. So main function, main int a. This int a is the similar type of variable we have already declared, int a. A is a variable of type int. Similarly, we are just declaring one struct keyword employee e. Means what is this? E is the variable and struct is the like primitive data type int. Struct is a data type here. Int is a primitive data type. Struct is a user defined data type. Okay, struct employee. This is the name of the structure, and e is the variable. Okay, is the variable. Two words are combinedly, two words are data type. Which two words? Struct employee completely. These two words, instruct, these two words, struct employee, combinedly two words are data type. Primitive data type is single word only, like int, float, character. This is the primitive data type. This is the primitive data type. It is a single word like int, float, character. But here these two words, struct, employee, are two words combinedly act as a data type, user defined data type, and e is a variable. Means here what we are doing, we are declaring a variable. This is the variable declaration. After this, this is just a Structure definition. This is the definition and this is the declaration of variable. So now when we declare variable, then only it will get the memory allocation. We are just declared the variable E of structure employee. So after the declaration of variable, it will get the memory allocation like this. E, for example, E is a variable and it holds the memory location. It is at the 2046. Suppose this is a memory address. Okay. Now maybe no. Now it will points to this three. What are the member of structures? E name, E number. Sorry, E name, E salary. So this E is a member variable. E is called now E points to the E name means 2046 address it is storing. So what we can, for example, this is also 2046 means this one, this 204 E number starts from means this, some memory allocation. These three members will get the memory allocation in memory means, for example, if the first base address is 204 and this E member variable, this variable is storing the base address, is holding the base address. Okay. Now E is called internal pointer variable because it is holding the address, it is holding the base address and it points to the location, means it points to the 2046 location. And at 2046 what is the value? E number. E number is the value. So means E, you are telling E is called internal pointer variables. But what type of variable holding address? Only pointer variable. So where is the pointer? There is no pointer. There is no pointer. E is act as an internal pointer variable because it is holding the address means base address, it is holding 2046 and at 2046 employee number is present means this structure, this all the member of structures means E number starts from 2046 and this address is holding by E. So E is act as a pointer variable, internal pointer variable means only pointer variable holding the address. So now the question is how many bytes of memory it will hold? Total how many bytes of memory it will hold? For example, int number. What is the data type of int number? It is int. It holds 2 bytes of memory. So the for example, starting address is 2046. And after holding 2 bytes, so the address be like that 2046 plus 2 is equals to 2048. Okay. Now E name, each character occupies 1 byte of memory in C language. Okay. E name and it is of character type. So character occupies 1 byte of memory. So total 20 characters. Then total how many bytes? Total 20 into 1 means 20 bytes of memory. 20 bytes of memory. And third is e-salary. E-salary means float type. Holds 4 bytes is equals to 4. Then 2, 20, 2 plus 20, 22, 22 plus 4, 26. Total 26 bytes of memory is allocated to the structure. Okay. Now, once we allocate the memory, how can we access the element of character of this structure? Means, how can we store the information? How can we retrieve the information? So, for this, in two ways, means this is the example of declaration structure variable. So we have already studied about this struct student character name 25, and age, character branch, and character gender. These are the member variables. And one important thing, the structure end with this semicolon. Okay, this is the definition part, and we will end by the semicolon. Now, struct student, this is the user defined data type, and S1, S2, these are, we can declare any number of variables. So we are just declare S1 and S2. These are the members of the structures. Okay, now there are two ways to declare. You can use structure student name and S1 comma S2, and second way is you can directly write after closing braces S1 comma S2. Both are similar. So my question is, once we allocate the memory, how can we access the element of that structure? Means how can we store the information and how can we retrieve the information? So structure member can be accessed and assigned values in number of ways. For structure variable using a dot operator. This is also called period or member access operator. Very, very important. To access the member of a structure, we are using dot operator. For example, e number, e name, and e salary are the member of structures. Okay, now e is the variable, which is we have already declared. E is the member. So e dot e name, e number, e dot e salary. We are using, it is very simple. Structure variable accessing is very, very simple by using dot operator. You have already declared a variable in the main function, means what e type, like struct M E. E is the member declaration member, and E dot E number is the accessing. This is the method of accessing. Now we can also use scanf to give the value to the structure members through terminal. Means scanf, directly you can give the value to the structure also. Scanf S1 dot S name, means S1 is the, in previous example, S1 and S2 are two variables we have declared to access the members of structure. Now what we are doing, we are just like variable of any other type. Structure variable are also initialized at the compile time. This is the compile time initialization. So scanf ampersand, percentage s is for string s1 dot name. This is, for example, this is the another example is struct patient float height weight int age. Struct patient p1. This is the initialization. We, up to this point we have cleared. Struct patient is the user defined data type, structure of patient. P1 is the variable we have declared. Now we can initialize by this also. This is also a way. P1 is equals to 180.75, 73, 23. What are these values? 180.75 is the height. Float means in which order you are already declare all the data members in your structure. This is the compulsion that you have to give the value or initialize the value in that order only. So 180.75 is the float, height, weight 73, age 23. This is the initialization part. Okay, now you can do initialization for each member separately, like this. Int patient p1, p1 dot height is equals to this, p1 dot weight is equals to 73, p1 dot age is equals to 23. This is also initialization. We can do separately and we can do in a single line. So like this, How now the question is how to find the size of a structure. Now the question is how to find the size of a structure. Here struct M, employee type structure, int employee number, character email, having size 20 means 20 character we can enter, float employee salary, closing of the structure, main function, opening braces, struct em, PE variable declaration, because by this variable we will access all the members of a structure we have already defined. This is the declaration part. Printf size of employee percentage D size of E means what we are doing, we are calculating the size of E, and E is the variable of structure M, means all the complete size, means total size or total memory. So size of E, or you can write like this also, printf size of M percentage D size of operator we are using. I am saying size of operator we are using. We can pass data type, we can pass this data type also, and we can pass this variable also. E is the variable and struct emp is the data type. So it will take either variable or data type. It will return the size of this complete structure into the integer forms. That's why we are writing percentage D. So how many bytes it is taking? 26 byte it will print at this position. Okay, now we can find the size by giving or by passing the variable or data type also. Okay, now like global and local variables, there are also local structure and global structures. Okay, what type of structures we should declare as local and what type of structure is declared as global? The means the structure definition common for all is called global. The structure definition common for all is called global, and the structure definition which is specific to a particular function, it is called local structure. Now the declaration of a structure inside a particular function means what I am saying, the declaration of a structure inside a particular function is called local structure, and outside to all the function it is called global structure. Now this is the example of local structure. The main function struct local int a b struct local L, means this is the structure and this is the variable. So this is another function, means there are two functions, main and check. Struct local L means this main definition inside the function, means what we are doing, we are just define the structure inside the main. This is the our main function, and this is the definition part of the structure. What we are doing, we are just defining inside the main function. So it is allowed, so struct L, it is allowed why you are accessing the structure only within that function where you are defined. So it is correct, because it is correct because we are just defining the structure inside the main function. And for in this case what we are going to do, local struct local L, this is another function. So it will throw an error undefined structure, because we are trying to access from outside. So it is not possible to access, because we are trying to access this variable outside the main function where it is not defined. We are just define this function, this variable inside the main function. So when we are trying to access in this check function, we are trying to access this struct local L in check function, it will throw an error undefined structure. Okay. So local means what? Only where you have already defined the structure, you can only use within that function. Or if you want to try outside it, it is not possible to access. Now, what are the global structures? Global structures defining outside to all the functions, like global variables you can use anywhere in the program or anywhere in any method or function. Okay. Struct global. This is a struct global. This is a global we can access anywhere. This is because we have already declared this one is struct global. This is global, we can access anywhere. Int ab main struct global g. This is what? This is the g variable which we have defined. So we can use struct global g outside the means anywhere in the program. Okay. So this is